In this problem, we're asked to find the resulting image from a compound lens system. We have a compound lens system. We form an image of the object using the first lens, and that first lens image becomes the object for the second lens. And we figure out the image formed of that, we can figure out the resulting image of the system. It's basically applying the techniques that we have for finding the image of an object given one lens over and over again until we've applied it for every lens in the system. So let's see how it works in this particular case. The first thing we have to do is we have to figure out where the image is for the first lens. And we do that in the following way. We use this relationship, 1 over s plus 1 over s prime is equal to 1 over f. In this case, the object distance s is specified in the problem. It's given as 25 centimeters. So we can write 1 over 25 plus 1 over s prime is equal to 1 over f. In this case, the focal length is actually negative, and so 1 over f is equal to 1 over minus 5 centimeters. Now we can take this equation here and we can solve for s prime. We find that s prime is negative. In fact, it's minus 4.17 centimeters. So where's this image form? Well, since s prime is negative, that means the image of the object that's formed by the first lens will actually be on the left side of the first lens, the same side as the object, since we have a negative image distance. And it'll be located 4.17 centimeters from the lens. Now, since we've now formed the image of the object of the first lens, the image becomes the object of the second lens. The second lens is 30 centimeters away from the first, and so we can calculate a new object distance. Let's actually not call it s prime, let's call it s2. And from the geometry of the problem, we can see that s2 is equal to a 30 centimeter difference between the two lenses, plus another 4.17 centimeters. And this is because the image of the object formed by the first lens is 4.17 centimeters to the left of the first lens. Namely now, the object distance for the second lens is 34.17 centimeters. Okay, once we have this distance, we can now calculate the resulting image of the second lens. We'll call it s2 prime, using this relationship. Okay, well, as I said, the object distance is 34.17 centimeters. We don't know s2 prime, the image distance. We know that's equal to 1 over s plus 1 over s2 prime, in this case, is going to be equal to 1 over the focal length, and the focal length was given as 20 centimeters. So now we can solve this particular equation. And we get that s2 prime is 48.2 centimeters. So that means that the image that's going to result here is going to result at a distance of 48.2 centimeters behind the second lens. Because s2 prime is positive, that means if the object is on the left, the image gets formed on the right of the lens at that distance. So we figured out where the image is located. The image is located 48.2 centimeters to the right of the second lens. And this is the part of the problem, but there's some other questions as well. For instance, we're also supposed to find the magnification of the image. Now we have a compound system like this with two lenses. The way to find the total magnification is to find the magnification from the first lens, then the magnification from the second lens, and multiply those two things together. In general, magnification is easy to determine once we know the image distance and the object distance for a lens. So in this case, m1 is going to be equal to the negative of, well, in this case, we actually had a negative image distance, 4.17 centimeters. So we put that in there, and this is over 5 centimeters, or excuse me, 25 centimeters. So we simply divide the image distance by the object distance. So there we have m1. We can calculate m2 as well. m2 is again equal to negative of the image distance, 48.2 centimeters. And this is divided by the object distance, in this case, 34.17 centimeters. In order to find the total magnification then, we just multiply these things together. This is going to be negative 4.17 over 25 times 48.2 over 34.17. When I multiply all these things together, I get minus 0.235. So there's a total magnification of the system. Now, there were even a couple other questions beyond this. One question was, is the image real or inverted? Well, s2 prime, the image distance from the second lens is greater than 0. Since this is the case, the image is real. Whenever I have a positive resulting S2 prime, or in this case a positive resulting image length from the second lens, I'm going to have a real image. So we know the image is real. Is it inverted? Well, the magnification is less than 0. That means that the image is flipped or inverted. And so now we've calculated all the properties of the image. We've calculated its position, its magnification, the fact that it's real, and the fact that it's inverted.